It came from the dark between stars, silent, fast, and utterly alone. On the 1st of July, 2025, an astronomer saw a dot move where no dot should move. Not an asteroid, not a comet, but something inbound on a path no gravity could hold. Astronomers spot it beyond the orbit of Jupiter and quickly realize it's not from here. Its path isn't bound to the sun, it's cutting straight through the solar system, an interstellar visitor we call 3I Atlas. Only the third object ever seen entering our system from the stars beyond. At first it looks like a comet, a frozen chunk of rock and ice. But soon, it starts breaking the rules. It wakes up too early, it shines too bright, and it moves with a strange steadiness that invites one simple question. If nature can do this by accident, could someone or something use these same natural forces on purpose? When astronomers first observed 3I Atlas, it was more than 4 times farther from the sun than Earth, well beyond where most comets remain dormant, but it was already alive, venting gas. At those distances, the sunlight is so faint it's like standing in the glow of a single candle a mile away, yet carbon dioxide ice was already boiling off its surface. That means 3I Atlas is loaded with highly volatile ices, especially carbon dioxide and carbon monoxide. These compounds vaporize at much lower temperatures than water ice, so even a trickle of sunlight can make them erupt into jets of gas. Those jets act like natural thrusters, pushing the object in the opposite direction, not by much, but enough to be measurable over time. It's the same principle as a balloon releasing air. Each puff of vapor gives a tiny push. Over months, those puffs can alter the course by thousands of kilometers. So, in purely natural terms, 3I Atlas is already propelling itself, powered by nothing but sunlight and chemistry. Now imagine a civilization that understands that chemistry intimately. Instead of engines, they build a vessel covered in layers of frozen gases, carbon dioxide, carbon monoxide, maybe methane, designed to wake at different temperatures and sunlight angles. By controlling which areas heat up first, they can choose where and when those jets ignite. They don't need fuel, they just need patience. The ship steers itself by breathing, venting a little more here, a little less there, always nudging its course using vapor as propulsion. This is the whisper drive, propulsion by outgassing. It's not fire and thunder like our rockets. It's the whisper of sunlight coaxing a surface to sigh. The beauty is that it doesn't look artificial. From a distance, it's just a comet, a natural object doing what comets do. But beneath that disguise, every puff could be intentional. Every shimmer a controlled exhale from a ship using nature's own thermodynamics as its pilot. If we interpret 3I Atlas this way, then its early awakening might not be a random quirk. It could be the first maneuver. By venting far from the sun, it could have been adjusting its inbound aim, refining its solar approach long before gravity took full control. Think of it as a pre-burn in interstellar navigation. Gentle, wide-arc steering across millions of miles, ensuring that when it finally enters the inner solar system, it's already on a precise, intentional path. The key insight is that even the faintest natural processes, if timed and balanced, can become tools for interstellar flight. Propulsion doesn't always have to mean violence. Sometimes it just means listening to the physics and letting the universe do the heavy lifting. As 3I Atlas moves closer to the sun, the comet's activity intensifies, but something unusual appears. The bright plume of gas and dust doesn't point away from the sun like most comet tails. It leans slightly toward it. That's strange, because the solar wind usually pushes material outward. The explanation may lie in geometry and rotation. If the nucleus spins and one hemisphere receives more sunlight than the other, the pattern of outgassing becomes uneven. Jets of carbon dioxide and water vapor burst from specific spots, and if the spin is just right, those bursts can seem to aim sunward, a kind of optical illusion created by timing, motion, and heat. Still, this asymmetry means one side is working harder than the other. The result? A small but consistent lateral thrust, enough to adjust the object's path in subtle ways, even if completely natural. Now imagine using that very imbalance intentionally. A vessel could be built with reflective ridges and venting channels arranged to create exactly this kind of asymmetry. By spinning at a controlled rate, the craft could modulate when each vent faces sunlight, effectively steering through light and gas alone. Each rotation is a calculation, each jet a correction. In our model, this is the gyrosail, a ship that uses spin to turn outgassing into propulsion. Its body acts as a gyroscope, and the vents are its sails. When sunlight strikes one face, vapor jets erupt, pushing sideways against the solar wind. By adjusting spin phase, the craft can translate or rotate itself without any onboard engine, just geometry, momentum, and vapor. To the human eye, it's still a comet, but in the language of physics, it's surfing the solar wind with mathematical precision. In this context, the sunward plume of 3I Atlas isn't just odd, it's expressive. It might mark the moment when the object began fine-tuning its inbound path, using asymmetric venting to shift its approach toward the plane of the solar system, the region where planets, probes, and observers like us reside. If that's true, then the shape of its coma isn't random. It's a gesture, a natural-looking but deliberate turn toward visibility, a quiet signal that its motion is not just a drift through gravity, but an act of navigation written in vapor, sunlight, and spin. By early October 2025, 3I Atlas slipped through the orbital neighborhood of Mars. From our perspective, it glides serenely, about 19 million miles from the planet, and yet its activity remains intense. Gas jets plume outward, dust streams away, and still the trajectory stays smooth and unwavering. Normally, comets vent unpredictably, their paths wiggling slightly as each eruption gives them a kick. But 3I Atlas seems balanced, as though every push finds its counterpush. Spectroscopic data suggest that its venting isn't chaotic, but symmetrical, releasing gases from multiple hemispheres at once. Even its rotation appears stable, not tumbling like most cometary fragments do after violent outbursts. So what we see, in natural terms, is a comet in equilibrium, a spinning body whose various jets balance so perfectly that the forces nearly cancel. It's like watching a top spin on the table, perfectly centered, steady, and self-correcting through the physics of its motion. Now imagine turning that natural equilibrium into a control system. A ship that never needs to correct itself because every vent, every reflective patch, every vapor jet is tuned to balance the others automatically. In our model, this would be the equilibrium engine, a form of passive stability where propulsion and control are one and the same. Each vent acts like a miniature thruster, but arranged so that when one side warms and vents gas, another side does too, balancing the torque. If the ship begins to rotate off-axis, the change in sunlight exposure triggers new vents to compensate, a feedback loop made of ice and sunlight. It's like an autopilot written in chemistry. No circuits, no computation. Just physics self-balancing, maintaining course by its very structure. For a civilization designing for eternity, this would be ideal. Nothing to break, nothing to run out. The environment itself keeps the ship in tune. And to us, from far away, it looks like perfect calm. If that's what's happening, then the Mars passage was not an accident, but a test of control. The object might have been entering a low disturbance phase, letting its outgassing stabilize before the most intense heat ahead, a kind of trim and hold maneuver before the solar dive. By balancing its venting so neatly, it ensured that when it crossed the orbits of the inner planets, it would do so with no loss of precision. The navigation here is invisible, no sudden turns or velocity spikes, just quiet stability, like a glider holding a perfect thermal. And that, perhaps, is the most remarkable part. Because whether by design or coincidence, 3I Atlas behaved not like a drifting rock, but like a vessel coasting in controlled silence through the gravitational lanes of the solar system. Now the real show begins. As 3I Atlas races inward, past 1.5 times Earth's distance from the Sun, the heat increases exponentially. Temperatures climb above the boiling point of water, the frozen gases ignite, and the object begins shedding mass at a breathtaking rate. The coma blooms into a glowing sphere of vapor, and the tail lengthens by millions of kilometers. At this stage, sunlight does more than warm the surface. It pushes it. Each photon, each tiny particle of light carries momentum. When it bounces off reflective dust grains or the smooth surface of the nucleus, it imparts an infinitesimal push. Normally, that pressure is too small to notice, about the weight of a feather on a house. But when an object is small, light, and reflective enough, those photons can add up. A body that reflects light well, especially if it's spinning in a controlled way, can actually use the sunlight as a form of thrust. Here, the line between natural physics and engineered flight almost vanishes. In our model, we call this the adaptive sail. Imagine a craft made of layered material, dark ices beneath, bright dust on top, so that as it rotates, it exposes more or less reflective area to the sun. By changing its orientation, it can steer using photon pressure alone, adjusting the direction of its tiny push. Its propulsion by patience, a whisper of force that never stops. Now combine that with controlled venting. The two forces, thermal and radiative, merge into a dual-mode drive, vapor for fine control, light for the long haul. In principle, such a system could steer an interstellar object with the precision of a spacecraft, while still looking entirely natural. Photon pressure and gas release now dominate its motion, shifting its trajectory in ways our gravity-only models don't quite predict. The sun itself becomes the engine, and the object responds like a leaf caught in a perfectly timed breeze. 3I Atlas may be showing us that interstellar travel doesn't need rockets, reactors, or reaction mass. What we call outgassing might, in a more poetic sense, be the conversation between matter and light, the quiet dialogue that carries a traveler from one star to the next. So what can we expect now? 3I Atlas is descending toward the sun now, falling through a gravity well steep enough to melt almost anything. By late October, it will reach its closest point, about 1 1/3 times Earth's distance. At that range, the solar flux is more than 50% stronger than what we feel on Earth. Temperatures will climb past 200 degrees Celsius. The upper layers of ice will vaporize violently. Cracks will open, vents will roar, and the object's brightness will spike as new jets erupt. Every comet does this, but in 3I Atlas, the composition is different. Carbon dioxide dominates, carbon monoxide and cyanide trace through it, and metallic dust adds reflectivity. That chemistry means perihelion is not just a brightening, it's a structural phase change. Deep-sealed ices reach their ignition point one after another, producing a sequence of outbursts, each one, effectively, a micro-rocket firing. If an intelligence wanted to steer by nature, this is where it would speak. Perihelion is the one moment when small forces matter enormously. The sun's gravity converts any added push, no matter how gentle, into a massive energy change. That's the Oberth effect in action. Now picture an object designed for this. Layers of volatile ices embedded along engineered fracture planes. As heat builds, each seam gives way in order, releasing a pulse of gas exactly when the orbital velocity is greatest. Each pulse provides a delta V, an incremental change in velocity, that compounds with the sun's pull. The direction of the jets decides the future trajectory. One vector sends it deeper into the inner system, another flings it outward toward another star. This is the fracture drive in practice, not hypothetical propulsion, but a testable mechanism. If such a design exists, the evidence is in the details we can measure. So what should we watch for? That's the falsifiable piece, the part that separates imagination from engineering. If the perihelion outbursts are random, brightness will vary chaotically. Jet directions will shift with rotation and the non-gravitational accelerations will scatter, averaging to zero. But if the object is controlled, 3 signatures will emerge. First, timing regularity. Bursts occur in discrete periodic intervals tied to its spin period, not random thermal spikes. Second, directional coherence. Each event imparts thrust along the same vector, producing a clean cumulative change in orbit rather than noise. Third, energy closure. The total delta V implied by those bursts will match the kinetic change we observe. No missing momentum, no unexplained scatter. When those jets fire, we'll have data, brightness curves, spectroscopic shifts, astrometric residuals. In those numbers may lie the first reproducible sign of a body using natural physics as deliberate propulsion. So the question isn't whether 3I Atlas is natural or artificial. The question is simpler, sharper, scientific. Does it maneuver as though it means to? If it does, we'll know by the pattern of its light. If it doesn't, we'll know that too. Either way, the answer arrives with the perihelion. In the end, 3I Atlas is more than an interstellar visitor. It's a mirror, one held up to our own curiosity. Every jet, every shimmer, every flicker in its tail is a question written in motion. What if the laws of nature are not just the background of travel, but the method? What if sunlight, vapor, and fracture can be used as tools, not accidents? Whether 3I Atlas is a natural wanderer or something that chooses its path doesn't change the real discovery here. The discovery is that we can tell the difference. For the first time, we have the means, instruments, models, mathematics, to ask the universe not what it is, but what it's doing. Soon we'll see the results of that experiment in the furnace of perihelion. Maybe the pattern of its light will be random, the noise of chemistry. Maybe it will be rhythmic, the pulse of intent. Either way, the outcome teaches us the same lesson, that physics is not passive, that nature already holds the engines of exploration, and that understanding them is the first step to joining the conversation ourselves. And if, as it rounds the sun, 3I Atlas turns just slightly more than gravity allows, then we will have witnessed something extraordinary. A traveler who speaks the language of the stars fluently enough to let the universe itself do the steering.